All right, ladies and gentlemen, boys and girls, it is balmy 20 degrees and nice and snowy out, and I am on my way to the dyno for the first time in a long time. And we had an interesting issue there. It was so cold. I complain about the cold a lot, but it was single digits for a while, and a pipe actually froze in the dyno, like one of the pipes. It has water in the building, running water, by the way. It's happened before, and it flooded the dyno bay, which has happened before. I don't know if I have told you or mentioned it, but flooded the dyno bay. Dyno was underwater. I'll see if I can find the picture. I was still in the process of working on the other house, and in between, and the little guy, and all of that happy horse shit was going on. And Troy sent me a picture of the dyno underwater. So it's another one of those things where they pumped it out, let everything dry for a couple days, and everything seems to be working. The only issue is, I'll show you video of this. The wheel speed sensor always gives me shit, and some of you might have even seen this in a bunch of my dyno videos where we have to fuck with the wheel speed sensor. And I'll explain the design, and I don't know if DynoJet still does it this way or if they have changed it. I'm going up a hill here, my Kia's bogging out. She's too old to be bogging out. Interesting. That was an odd car. Anyway, it has a photo sensor, and there's a little tooth on the wheel of the dyno, the 24-inch roller that's like 2,000 pounds. And there's a tooth on the roller, and there's a little photo sensor. Stick shift. There's a little photo sensor, and the tooth has to go in between the air gap on the photo sensor. And I will show you this photo sensor. It has like a 3mm or a 1mm fucking air gap. It's just like a couple pieces of paper and like a 16 gauge piece of steel has to swing in between it, and it gets dirty. Since it's a photo sensor, it has to break the beam between the two plastic towers, and it's in a pit filled with brake dust and shit all day, so it gets all grimed up. I'm left-hand shifting behind some dump trucks that are going super slow. It's a good thing my Kia is a dump truck also. We can all pace each other. So what I've always wanted to do was, anyway, brake dust gets on this photo sensor and it stops working. So you stop seeing mile an hour, and then the dyno can't figure out how fast the drum is spinning. It doesn't know the workload, blah, blah, blah. You get no data, or you get shit data, or you get all sorts of weird jaggies. And that goes up and down. So what I'd like to do is it's a 3-wire sensor. So one presumes that this is like a pulses per minute. So the beam break is the pulse, and then it figures out how fast the drum is spinning by the breaks, the pulses. Because a 2-wire would usually mean it's a VR sensor, and the 3-wire usually means it's like a 5 to 12 volt sensor, and it has a 5 volt ground and a signal wire, a pulse wire, or whatever you want to call it. Anyway, what I'm getting to here is I said I want to use an LS crank sensor because it's a 5 to 12 to, similar. Electronics are usually like 3 to 30 volts. They're regulated somewhat inside, and they can just take voltage like an ECU, 9 to 24 volts usually, right in there, and regulate it to what it needs to use, the 5 and 12 volts internally, whatever. I would love to use a Hall effect sensor, the LS crank trigger sensor. That would be awesome if I could use that, because it wouldn't get dirty. Basically, if you look in an LS motor, it has an oil-filled crank trigger that it's reading all the teeth off of. So if I put that in the dyno bay and I line it up with the teeth, it should work. It should work really good, hopefully. Anyway, so I'm going to try to figure out which wires are which, and I brought my multimeter, so I've got to figure out like voltage and ground, and then the 3rd wire is signal. So then all I need to do is match it up to the crank position sensor, and then wave like a screwdriver in front of it, and I should see mile an hour input. And if all of that is possible, I just have to mount it in a way that it is close to where the tooth passes in front of the crank position sensor. So hopefully I didn't run on this too long. I'm driving and thinking about what I'm doing. Anyway, we're gonna open up the dyno floor, we're gonna take a look at the sensor, we're gonna try to graph the other sensor in. I'm gonna pop open, the dyno uses an air cylinder that pushes a hydraulic boosted master cylinder into two slave cylinders that push train brakes up against the roller like this and stop the roller. And this is, people have told me the design has changed immediately after this. Maybe the engineers figured out that they did a horrible job, or they figured out a better way immediately, because if you have any problems, you have like 10 systems to work on. What I heard they do now is it's a giant L cantilever, and an airbag fills and it pushes the brakes. And it needs no adjustments until the brakes wear out, and that's it. Now that would be fucking nice, now wouldn't it be? No, I have only as much throw as the slave cylinder will give me, and then the brakes don't work on the dyno, and then the slave cylinder needs to be adjusted. And then if you pound on the dyno a lot, like we do a dyno day, you can get the drum almost to the point of where it's like turning colors, it's so hot. And what that does is it boils the brake fluid, and then what that does is fucks everything up. Anyway, it was underwater also, so if it drew water into a bunch of the stuff, it's gonna rust and go bad. So I gotta make sure that the water's out of everything and there's brake fluid in it, and try to swap out the sensor and then see if everything works. And then if the LS crank trigger can go on there, it would just make me laugh, since like LS everything. LS the dyno. We're gonna LS swap the dyno jet. That'll be the title of this video. I'm LS swapping my dyno jet. Clickbait, not clickbait, but yes, clickbait. So we'll see how all that goes. And then I'll do a video later today when I get home. I have a bunch of fuel injector stuff that I'm doing to my truck, changing injectors. I have a couple different sets of injectors people sent me. I bought a set, injector harnesses, fuel pumps, talking about all that stuff. We'll summarize and then we'll go from there. All right, and here we are in the super loud dyno bay, because there's actually a heater running and the mechanic is doing a brake job, and there is my buddy Def Glenn, the cameraman. And here is the sensor I was talking about. I got it apart and I'm doing the voltage testing right now. I'm just showing everything. Obviously you can't hear shit. So this is the sensor, that's the plug, and that's the tower, the photocell. So you have to pass something between that gap, the tooth on the dyno. And then this is the LS sensor. That's what I plan to, trade places with if all goes well. So then I do some testing with Glenn. You can see there's the little plug right there. And I show here, actually, I take a Dents, Dings, Interior Things business card, and that's what the tooth is doing on the dyno roller. Yes, and sometimes smashing into it also. And there's not much of an air gap. Like, that lead is not very big. And we were lucky enough to have cameraman Glenn with us today. So what I did is I was like, hey, just show them where it shows mile an hour. That's how you know the photo sensor's working. And I'm like, hey, look at me go. Very professional testing here. And then my concern was, is this a 5-volt sensor? Will the LS sensor work? So I brought my multimeter, and there's literally a red and a black wire on the wiring harness. And when I connected them, I got 4.9 volts, which is 5-volt sensor. So we're good to make a dry run and see if it'll work. And then obviously, exciting moment here, I jammed the wires in the connector, wave a screwdriver over it, and I got mile an hour. So this will work. I'm pretty happy about this, obviously. Okay, and here is after the dump truck was moved, I could spin the roller and obviously bend my bracket enough that nothing would get hit and ruined. So this is after I lined everything up, spinning the roller, see the nice mile an hour. And then this is to give you an idea of what's going on down in the pit. I grab my light and the camera and I jam them down in there together. You can see the crank position sensor just sitting in there, amazing. And I made that scratch mark right where the tooth is, and it is working awesome. Okay, and now here is the test and see if this thing works at speed. So I strapped down my tow truck utility van Kia here, and we'll make some pulls and compare them to how the thing has dynoed over the last couple years to make sure the sensor data is correct. Now what makes me laugh here is to hear how loud the roller seems, but it's because the Kia is so damn quiet. It sounds like it's shot. And one more quickie here to make sure all the results back up over multiple passes. And here are the results, which are pretty good. Pretty much the same damn thing. The only difference is it's electronic throttle, so it's hard to tell what it's doing down low, but they're nearly perfect traces, except for, I mean, you can hear this thing ping at the top of the pole where it pulls a little bit of power, but they are like a mirror image, so gotta be happy with that. LS crank position sensor is working great. All right, it is nighttime, and as you saw, the LS sensor, crank position sensor, works great. It works even better than the stupid factory one that is a pile of junk. So I'm happy to show how well that works. More than pleased with the results, and we will continue. I hope I showed the zip ties. I zip tied the damn sensor. It looks great. I think it looks great. So we will see, you know, longevity of that, but I can't imagine that a sealed crank position sensor unit in something as light duty as that, which is used to sitting in the side of a hot engine block with hot dirty oil slung against it its entire life, won't work as well as that circuit board. So we'll keep you updated, but I think it'll be much better. Obviously it's easier to install, easier to align, a cheaper part. I should call DynoJet on the phone and see how expensive that piece of shit circuit board is. I bet it's $300 or something outrageous. And now it's an LS crank position sensor. I should sell DynoJet a retrofit install kit. See if they'll buy it from me. Anyway, that's it for tonight. Hope this was informative. And if you have an older DynoJet, now you know what to do.